How we solve quadratic equations in general and how we would do this one. We've gotten to the point now where we know how to do it. We've really learned everything we need to know about solving quadratic equations. There's only 3 ways we would ever do it. If we had an x that we could isolate, if there were a single x, what would we do? I guess I kind of gave it away. Yeah, we would isolate it, right? If you can point to a single x, remember you can always isolate it. And how do we do that? By doing what? How do we isolate a variable?
Get everything else on one side.
Okay, get everything else on one side. And what's the order of the operations we would apply there?
Backwards.
Good. PEMDAS backwards. We're going to reverse PEMDAS for that. Good. Okay, so this is not one of those cases, though, is it? There are multiple x's here. So what do we have to do in a case like this where we have more than one x? Okay, we got to simplify it. Good. So what does that mean here? What are we going to try to do? What do you think? Good.
Subtract 2x squared and add it to 5.
Okay, subtract 2x squared. What else, maybe?
And then subtract 5. And then subtract 5 and
So,
-1.
okay, so we're going to want to, our goal is to put this into, remember, what's called standard form for a quadratic equation, which just means it's all set equal to what? 0, right? So we want to get this to look like ax squared plus bx plus c equals 0. That's a quadratic equation in standard form, right? So, and you'll tell me how to do that in a second. Judith got to start. That was right. We want to, for example, to kick the ball off here, we're going to subtract 2x squared from both sides. We'll do some other things too. Once we get to this point, though, where the quadratic equation is in standard form, we don't have to do any real complicated algebra anymore because we now have a formula for it, right? We know that the solutions to a quadratic equation in standard form by the quadratic formula are x equals negative b. Nice. No, minus.
Oh, minus. Oh, good.
No, b squared minus 4ac divided by 2a, right? Okay, so there's our. So there's our quadratic formula, right? And if you can't, we'll never forget the song, I'm sure. So all we have to do at this point, once we get our, we're not quite there, but once we get our equation into standard form, we just identify the values of a, b, and c, plug them into the formula, and get our answers. Just simplify to get our answers, right? Okay, so this is where we need to get. What do? We subtract. Which side are we going to push all the terms onto, I guess, is a better question. The left. How come? Okay, because there are more x squareds over there, and the one thing that we want to make sure we do when we put this quadratic equation into standard form, we want a to be, positive, right? We want to have a positive a. If we don't, it makes things harder, right? Okay, so we're going to push everything over to the left. If I subtract 2x squared, that's going to leave me with 3x squared over here, right? Okay, you guys getting this?
Yeah.
Okay. 3x squared, I'll subtract the 8x over to this side. And then when I add 1 to the 5, I just get what? Plus 6? Okay, agree? All right. So there's my quadratic equation in standard form. Now, if I can, I'll simplify that a little bit. If there were, like if that 8 were a 9, for example, instead of an 8, I could divide both sides by 3 and make it easier, right? But there is no common factor of 3, 8, and 6. And so we're stuck with it the way it is. So what's A for us? 3. What's B? Negative 8. What's C? 6. Okay, good. So we end up with then x equals, we're just going to substitute into the formula. What's negative b? 8. Just the opposite of b is all that means, right? So 8 plus or minus the square root of Okay, negative 8 squared, but what do we do when we square a negative? Square the positive. So 8 squared minus, I would write it this way too. I'm not going to insist that you do this, but I just highly recommend it. 4 times, and then write the other numbers there in parentheses, maybe when you're writing it at least. 4 times 3 times 6, right? So that we can count the number of negative signs. How many negative signs? 1. Good. So if there's one negative sign, then that's telling me that that product of 4 and A and C is going to be positive or negative? Negative. Good. Okay. And then it's all divided by 2 times 3. All we have to do is simplify that. That's it. And it's the same process every time you use the quadratic formula. So you get pretty good at it pretty quickly. All right, so what do we get then? 8 plus or minus square root, what's 8 squared? Okay, what's 4 times 3 times 6? 4 times 3 is 12. Times 6? 72. Good. So minus 72 all over 6, right? Equals 8 plus or minus the square root of what? Negative 8. Okay, so what do I've just got to simplify this now. What do I do with that radical? Okay, I'm going to have a square root of 8i because I've got this. I've got that negative number under the radical, so we know that's going to become an I outside of the radical, right? Then the other thing I could do is I could simplify the radical, simplify the square root of 8. What's the biggest perfect square? It's not very big, but what's the biggest perfect square that divides into 8? 4, right? I could break the square root of 8. Square root of 8 equals the square root of 4 times the square root of 2, and the square root of 4 is just 2. So we end up with our answer being 8 plus or minus 2 times the square root of 2 simplifies the 8. And then we've got an I, and it's all divided by 6. Now our goal though is to we want to write this, we've got i's in our answer, so we're writing complex numbers. We want to write the complex numbers in separated standard form, right? So we want to write them in the form a plus bi, right? So if I split this into separate fractions, I just get 8 over 6, which reduces to 4/3, plus or minus, what about this part? 2 times the square root of 2 over 6. What could I divide each of those by? 2, right? So on the top I'd get what? 1 times the square root of 2, and I wouldn't even write the 1 then, would I? 1 times the square root of 2 is just the square root of 2. On the bottom I'd get a 3, right? And then I'd get my I. You could put the I in the top if you want to. Probably better to put it at the, following the fraction. But you just can't put it inside the radical. That would be incorrect. Okay? So in Moodle, I need to enter those separately, right? In Moodle, it specifically asks, this is a question that's going to ask you for exact simplified solutions, aka no decimals. It's got to be radicals, fractions, they got to be exact answers, not rounded decimals. And so we would have, and it wants them separated by commas if there are multiple solutions. So we would just go 4/3 plus square root of 2 over 3i, comma, 4/3 minus square root of 2 over 2i. Okay, make sense? Okay. Now, we looked at an example yesterday, didn't we, about how to use a graphing calculator if decimal answers are okay, right? Right. Okay. So you're probably fine with that. The last thing I want to take a look at is, say it again. Question? Oh, it should be 3. My mistake. Okay, last issue. Now, when you look at the quadratic formula, okay, I want you to tell me here, what about the quadratic formula? What part of that is going to tell you if you are going to get I i's in your answer or not? I mean, why do you get i's in an answer? Okay, because you get a negative number under the radical, right? That's what's going to tell you if you get i's or not. So the part that if we wanted to, for example, and there are going to be some questions that ask you to do this, where I don't even care what the answer is. They're just going to say, I want you to tell me what kind of answers are you going to get, and how many of those are you going to get, right? All I really would have to do then is focus on the part of the quadratic formula inside the radical. And that's actually what we call the discriminant, the part that sits under the square root sign, okay? Why is it called the discriminant? Because that's a really good word for it. What does it mean to discriminate among choices? So if now think about that, I know there's kind of a negative, obviously, connotation with discrimination, but really discrimination, the word itself doesn't mean anything negative. If you have discriminating taste in food, what does that mean? You like a certain type of food. It kind of implies you like good food, right? So you like a certain type of food. So to discriminate really means you're going to make a selection based on the available choices, based on the qualities of the available choices, right? So you could have discriminating taste in food, or you could discriminate between the colleges that you are applying for. You want to pick the right one. So to discriminate means to choose, to separate the choices at least, right? So the discriminant does that. The discriminant tells you what kinds of solutions you're going to get and how many. Think about the only three possible differences that would be meaningful to us. We have a positive discriminant. What's going to happen if we have a positive discriminant? So D, which just represents b squared minus 4ac. What if that number that we get is greater than 0, so it's positive? What's that going to do to the quadratic formula? If I get a positive number under the square root of a positive number is what, positive or negative? Positive, right? So I'm going to get x equals negative b plus or minus some other number divided by some other number, right? Would you agree that I'm not going to get any i's in my answers then? Right? I'm going to get one answer for the plus sign and a different answer for the minus sign also. Do you agree with that? Does everybody see that that has to be the case? Okay, so then if I wanted to describe what's going to happen when the discriminant is positive, how many solutions am I going to get? 2, one for the plus, one for the minus. And what kind of solutions are they going to be? Well, maybe positive, maybe negative, but they're not going to have i's, right? So how would we say a number that has, how would you describe that? Real, right? We're going to get real number answers, no imaginary parts. So this is going to give us 2 real solutions, guaranteed. Okay? When the discriminant is positive, meaning the part inside the radical gives you back a positive number. Okay? What if, on the other hand, what if the discriminant is negative, meaning it's less than 0? What's going to happen there? I'm going to get 2 answers, but they're going to have i's in them. And that's exactly like the case that we just looked at, isn't it? Right? I'm going to get 2 answers, each of them with an I. And so that's going to be a case where I get 2 imaginary solutions, right? Okay, what about the in-between case? What if the discriminant happened to be exactly equal to 0? Now think about that. Let's look at the quadratic formula for a second. If b squared minus 4ac is 0, I'm taking the square root of 0, right? What is the square root of 0? 0. So then my answer would look like negative b plus or minus 0, right? All over 2a. Is adding 0 and subtracting 0, those mean different things? No. In both cases, whether I add 0 or subtract 0, don't I just get back the same result, negative b over 2a? So what kind and how many solutions am I going to get if the discriminant is 0? I'm going to get 1, and it's gonna be real, no eyes, right? Make sense? Okay, I think now you should go try some.
Can we leave?
Yeah, we're done. I gotta tell you where we're going though, so hang tight for 1 second.